On an open concrete pad, the surface layer began to deteriorate after just the first winter. At the expansion joints, the concrete has chipped and crumbled away. We see the defect. Now we'll determine the cause. In summary, 3 types of defects were identified on the site. On the concrete surface, we see a defect called scaling. This is the disintegration and chipping of the surface layer. At the expansion joints, we see deeper concrete chipping and crumbling. This type of defect is called spalling. Tapping showed that in some places, the surface layer has already delaminated, though it's still in place. This type of defect is called delamination. Initially, there was a suspicion that the concrete used was unsuitable for these specific conditions. However, the documentation showed that the chosen concrete was resistant to the effects of frost and de-icing agents. So why did it fail? The investigation revealed a key factor. The site was paved in the autumn, and de-icing agents were already being used during the very first winter. We often encounter the common misconception that concrete acquires all its design properties after 28 days of curing. That is not true. After 28 days of curing, concrete reaches its design compressive strength. However, it has not yet acquired other mechanical properties, nor has it gained resistance to environmental factors. Authoritative technical sources provide varying recommendations. It is recommended not to use snow and ice melting agents for at least 3 months after installing the concrete surface, and ideally not to use them during the first winter after installation. Young concrete is still moist, and the structure and durability of its surface layer continue to develop. The de-icing material melts the ice and forms a solution that is absorbed into the concrete surface. As a result, the concrete remains heavily saturated for a longer period. When such concrete freezes, the pressures that form in the pores more easily damage the surface layer. Repeated exposure causes microcracks, the surface layer delaminates, and later begins to flake off. During heavy rains, the solution could remain longer and soak the edges of the concrete more thoroughly. Once the concrete is weakened, it's further affected by joint movement and traffic loads, which led to deeper chipping and spalling here. The most likely cause of the defect is the premature use of de-icing materials. The concrete was chosen correctly, but its surface was too fresh and not resistant enough to such intense exposure.